Women in Science have the power to change the world. Discover Women in Science, presented by the L'Oréal Foundation.
In the world of science, will the 21st century be that of the human brain? Researchers are sure it will. 7 million years after the birth of the first humans, the brain still has not revealed all its mysteries. One woman, scientist Brigitte Kieffer, has joined a crazy race.
I warn you, I walk fast.
To unlock the secrets of the human brain, the most complex of all organs, with the hope of one day being able to treat the terrible disorders that cause diseases as diverse as they are unpredictable, such as schizophrenia, Alzheimer's disease, or drug addiction.
There's one in the middle, right?
To date, according to the World Health Organization, 1 person in 4 has already suffered from mental problems during their lifetime. In Montreal, Canada, Brigitte Kieffer presented her latest findings. So many reasons for hope in the future.
What I like is venturing into the unknown, to new lands, doing things that have never been done.
The story of Brigitte Kieffer is above all that of a place, an institution in Montreal on the banks of the St. Lawrence River. Since 1881, the Douglas Hospital has taken in patients with mental disorders. From the very start, the Institute's researchers installed their laboratories as close to the patients as possible. Several generations of scientists have succeeded one another. For 20 years, neurobiologist Brigitte Kieffer has earned a reputation for her research at IGBMC in Strasbourg, France. Recognized several times for the quality of her work, in 2014 she finally chose a new challenge: to go to Canada and be in direct contact with patients.
At that time, like anywhere in the world, people didn't like madmen, and psychiatric hospitals were always built out of town. So this hospital was outside Montreal. Here, the patients live with us, in fact. We see patients every day. And of course, the doctors are our colleagues, and many doctors do research.
Does that give you extra responsibility?
That shows me the gulf that exists between the treatment of a psychiatric patient today. It's like prehistoric times. Between the meager resources that exist today to treat patients and neuroscience, which is advancing very fast. For now, there's a huge gulf between the two, and we absolutely must fill it.
To fill this gulf and to develop new treatments, researchers have embarked on a Herculean project to establish the map of the human brain in order to understand its connections. To this end, the first surprise is the laboratory has acquired a scanner especially calibrated for mice. It may come as a surprise, but the genetic makeup of this mammal is 98% identical to that of humans. Though the volume is smaller, the rodent's brain enables us to identify how areas of the brain communicate between themselves to express certain emotions.
Hello. So, what do we get? C'est mieux avec la cryoprobe?
The scientist has never ceased to wonder at the workings of the brain.
Ah, c'est génial.
Oh, that's great. That's great. Look at that. We can see that each small region of the brain is active. Can't you see the mouse's brain teeming with activity? You see?
Where exactly?
Everywhere. Can't you see it sparkling and moving? Our behavior is decided by a set of networks that will work at a given moment to generate a behavior, an emotion or a feeling. Here, we have to understand how the cells function and also how the networks work amongst themselves. I think there's a potential in the way the brain works that we're a long way from understanding, but that we will discover wonderful things. The big leap in biology was the genome. We sequenced the human genome in 2001. The next big leap is the brain.
And this great leap carries the hope of millions of patients who suffer from diseases that, for now, are incurable. To carry out its research, the Douglas Institute has a scientific treasure placed under high security on the top floor of the building. Here, they call it the Brain Bank. Behind these doors, more than 3,000 human brains left to science by sick patients so that researchers may one day find the causes of these terrible diseases that have destroyed their organisms.
For example, here we have human brains preserved in formaldehyde.
In this room, for example, the brains of patients who suffered from Alzheimer's disease.
Each brain is a person who has lived with their own experience, be it family, psychological, everything.
The person's entire history is recorded, so these aren't anonymous brains. This enables us to know what we should study, what we should be looking for, and what we may discover.
Inside these brains, a mine of information on all cerebral disorders, which generate mental illnesses, depression, and even suicide. All this is of interest to researchers all over the world. This bank, one of the largest in the world, sends more than 1,000 samples each year.
So here I can tell you that it's a human hemisphere, and you can see that it's anonymous. And you can see inside that these are slices. It's gray gold, as in gray matter. Recently, we sent some to Brazil. Some are going to Asia, to China. So that gives you an idea of the scope of demand and the bank's reputation.
To build a platform, a resource like that, there have to be doctors, a legal system, you need psychologists. It involves a lot of people. Every brain is different from the next, harking back to the idea of fingerprinting. There are inflammation markers that we can study very well in samples of human brains, which are the consequences of psychiatric illnesses. And this idea that psychiatric illness is also linked to a form of inflammation of certain areas of the brain is quite new.
It's even a scientific revolution. For a long time, bad behavior was identified to explain mental illnesses. But Brigitte Kiefer is convinced that a biological disorder is behind depression, schizophrenia, and drug addiction.
Psychiatry is a very difficult area, especially mental illnesses, because we have trouble quantifying them. It took a long time to realize that the brain is an organ, that there's biology, that maybe we can learn its biology and one day understand the biology that is behind behaviors, and hence dysfunctional behaviors.
It remains to be seen why the system goes off the rails. Brigitte Kiefer thinks she has part of the answer. Since the 1980s, the researcher has specialized in the study of a key mechanism: receptors. They're found on the surface of cells in the brain.
They are switches that react to external stimuli and that will regulate the functioning of the neuron.
These receptors, once they're activated, will generate our behavior. In 1992, in her laboratory in Strasbourg, France, Brigitte Kiefer was one of the first in the world to identify the delta opioid receptor, at the time a discovery that caused a stir worldwide. The delta receptor is the one that generates in your brain the feeling of euphoria and also causes addiction once you have consumed drugs.
So that day was like picking a lock. Anything became possible in that domain.
Since then, the researcher has been looking for other receptors. It's a daunting challenge. There are still about 150 orphan receptors in our brain whose function and role we're still unaware of.
We don't know their exact location in the neuronal circuits, so we don't know how the activation of these receptors inhibit pain, for example. So here you have receptors that act as painkillers in these cells, whereas elsewhere in other regions of the brain you have the same receptors producing euphoria.
Controlling these receptors will soon lead to the development of new drugs capable of activating the right connections in the brain.
Hi, Alisa. I guess we'll have some visit.
At least, that's what Brigitte Kiefer hopes. And her team is on the verge of succeeding in a crucial area, that of drug addiction. For centuries, because of morphine and its derivatives, medicine hasn't managed to treat the pain without patients becoming addicted to these drugs at the same time.
Actually, the long-term goal is to find an ideal analgesic that would not be addictive, so a morphine that would not create addiction. You will try to separate in the drug structure, what is capable of inhibiting pain, which we believe is recruiting specific signaling pathway in the cell, from what will trigger euphoria. What we do here is of importance.
This biological approach has drastically changed our understanding of mental illness. And Brigitte Kiefer wants to go even further by building a latest generation molecular psychiatric center, a $50 million project. In Montreal, Canada, she is tirelessly enlisting the support of the scientific community behind her project.
High-level scientists like Brigitte are making it clear to both scientists and the general public that these are illnesses based on molecular and cellular mechanisms that we can understand, not just saying it's their problem, they're a bit weird, like the prejudices people might have. Because, unfortunately, there's been a disengagement over the years by some pharmaceutical companies with respect to these diseases because of their complexity and because of the stigma that accompanies them. We have to fight against this to ensure that our society has the resources to be able to tackle this problem.
Brigitte Kiefer's team's next discoveries are eagerly awaited. It's a race against the clock, because brain diseases are becoming more devastating. Each year, for example, according to the World Health Organization, 8 million new cases of dementia are recorded. 1 person out of every 5 in the world today suffers from depression at some time in their lives.
Women in Science was presented by the L'Oréal Foundation.